In this video, we're going to take a look at stoichiometry with limiting and excess reactants. We sometimes also say excess and limiting reagents. Reagents and reactants, it means the same thing, the starting ingredients or the starting materials for your reaction. So these are our learning goals over here. We're going to be able to determine what the limiting reactant or reagent is in a chemical reaction, and then use that limiting reactant or reagent to solve problems relating to stoichiometry. So let's go ahead and take a look at what a limiting reactant is with a bit of an analogy. So remember that we always start off with a balanced equation, and the balanced equation tells you essentially how much reactant you need to make a certain amount of product. And in that balanced equation, we give you sort of that basic recipe. So everything is used up and everything is produced like it's supposed to be produced, and there's nothing left over. So for example, here we have these 4 wieners over here and these 4 hot dog buns over here. And those are the 2 ingredients required, and that will make essentially 4 full hot dogs over here. Nothing left over, 1 for each bun over there, and we get our full 4 hot dogs. But as we know, in the real world, recipes don't always work out that way. Sometimes we have leftovers, or sometimes we purchase a bunch of ingredients and we hope to make a certain amount, but we run out of something before we can make the full amount that we wanted to. And that's the idea behind stoichiometry and limiting reactants. It's really how most reactions work. We will never really have this perfect balance of reactant 1 or reactant 2 making exactly what we need with nothing left over. What will happen is typically one thing will run out first and then prevent us from being able to make more. Let's take a look at an example of that. So if we look over here, we have 1, 2, 3, 4, 5 of these wieners and only 4 of these buns. And so you have to estimate how many full hot dogs you can make. Now, if you mistakenly said that because you have 5 wieners over here, you can make 5 hot dogs, full hot dogs, you'd be wrong. Because what you forgot is that you only have 4 hot dog buns, and so those will run out first and then prevent you from making any more. So this is more what reactions and actual things look like in the real world. So we're able to make 4, and then we have some left over here, which is the 1 wiener here. And the reason we couldn't make more is because we ran out of the hot dog buns first. So this brings up the concept of a limiting reactant or reagent and excess reactant or reagent. The limiting reactant is the one that essentially runs out first, the one that stops the reaction or limits how much you can make because you just ran out of the quantity you needed to continue the reaction. And the excess reactant is the one that you have more than enough of. So for example, I have a leftover wiener over here. So it's generally your leftovers. You have more than you need of it, and that's called the excess reactant. So the one that that's gonna limit your reaction, that you'll run out of, at least to continue the reaction, will be the limiting reactant, and the one that you'll have left over of that you have plenty of is your excess reactant. And as we just stated, when you're estimating how much you can make, you really need to focus on your limiting reactant. You can't focus on your excess reactant because then you'll assume you can make too many, right? So again, imagine you have to feed 5 people full hot dogs, and you say, well, I'll have enough food because I have 1, 2, 3, 4, 5 wieners here. I can make 5 hot dogs. Well, you'd be wrong. So you show up to the party with 5 people there, and there's only 4 hot dogs available because you forgot that you had to estimate based on what you run out of first, which is the hot dog buns. So you always have to make your estimate of what you can make using the limiting reactant. Otherwise, you overestimate what you can make if you use the excess reactant or reagent. And over here, you can see a different explanation of the limiting reactant using a different analogy. You might have analogies in your own life that you can use in your study notes. Maybe you can share it with some of your peers as well, because it might be a bit easier to understand for you if you have other examples that you can provide. So let's take a look at another analogy here. Let's answer some guided questions together. So we have our reaction up here. 2 breads, 1 ham, and 1 lettuce is 1 sandwich. And so I know what a lot of you are thinking. Where's the mayonnaise? Well, I know it's not there. Where's the ham? Where's the mustard? It's not there. It's okay. This is just to illustrate a point. So 2 breads, 1 ham, 1 lettuce, and make 1 sandwich. So if we take a look at these items here, we have to see how many sandwiches we can make. So try to predict how many sandwiches you can make based on the ingredients that you have. Now, if you count the amount of bread, you might say that you can make 3 sandwiches. This would be 1, this would be 2, this would be 3. But you got to be careful because maybe your reactants, your other ingredients might run out first. So let's go double check. It looks like we have enough to make, it looks like we do have enough. If we look at lettuce, it looks like we can make 3 as well because it's 1 lettuce per sandwich. So you might say you can make 3, but let's take a look here. If you look, we need 1 ham per sandwich. We don't have 3 hams. This is going to run out before we can make our 3rd sandwich. So in reality, we could only make 2. These ingredients here, these ingredients over here, and then we're out of ham. And the ham limits how much we can make. So we can say that our ham is considered our limiting reactant because we ran out of it, or we ran out of the amount we needed to make more sandwiches. And then any leftover is really considered our excess reactant or excess ingredient or reagent. So for example, we'd have leftover bread over here, and then also leftover lettuce. So we can make 2 sandwiches with these leftovers over here. We ran out of ham. That limits what we can make. And so that's really what we have to consider when we do chemical reactions as well. Because when you're doing reactions, you're mixing ingredients together to make products. One will run out first and the other won't. And it's the same idea. The one that runs out first is going to be your limiting because it stops the reaction. You can't make any more without it. Doesn't matter how much more bread, for example, that I add. If I don't have any more ham, I cannot have any more sandwiches. So I could add 100 more pieces of bread. Doesn't matter. As long as there's no more ham that I added, I can't continue the reaction. To actually continue the reaction, you'd have to add more of the stuff that was limiting so you can continue going forward. And then you can take a look at another analogy. So if you're a car person, you can take a look at analogies with building cars. Are there any limiting reactants here? If there are, what is the limiting reactant? Is it the car bodies or the car tire? Which one runs out first? And then which can you use to make your estimate? So for example, if we look at this picture, and you can try to think about it before I say it, you can pause the video. If you were to assume that you could make 2 cars based on the frame here, maybe you're right, but let's go look at the tires. Each car needs 4 tires. So we have 1, 2, 3, 4, 5, 6, 7 tires. So if you made the estimate that based on these 2 frames here, you could make 2 cars, you would probably be incorrect. You'd fall short somewhere. And what you'd notice is, you can make 1 full car, but then you wouldn't have enough tires to make the other car. So essentially you ran out of tires to continue the reaction. So what's limiting you here, what's preventing you from making more cars is really the amount of tires. It doesn't matter how many more car frames or bodies you add. You're not going to be able to make more unless you put more tires there. Let's go take a look at a more chemical example now. So here we have a chemical reaction. We have 1 carbon plus 1 oxygen produces 1 CO2. And so here are the carbon atoms, it should really say. So we have 5 carbon atoms. And then here we have 10 oxygen molecules. So based on this balanced equation, if I have 10 oxygen molecules, because it's a 1-to-1 ratio here, I should be able to make 10 carbon dioxide molecules. So you could make that estimate. You could say, well, 10, 10. Okay, that makes sense. But you have to look at the other reactant as well. Notice this is a 1-to-1 ratio here between carbon and carbon dioxide. So if you have 5, you should be able to make 5 carbon dioxide. So who do you trust more? Well, if you take a look here, this one will combine with this one with this one, this one with this one with another one over here, and this one with another over here. So you're going to run out of carbons faster than you're going to run out of oxygens. You'll have leftover oxygens, essentially. So because you have leftover oxygens, these are your excess, and your carbons ran out, so they limit how much you can make. Theoretically, you could have made 5 more carbon dioxides, but you just didn't have enough carbons left there to continue the reaction because you ran out. So the carbon atoms here are my limiting reactant, and then the oxygens are my excess reactant. And so here you can see the product made, and then you have the excess oxygens, which won't react unless you add more carbons in there. You can add more and more oxygen in there, but it won't really do much because, well, we don't have anything else to react with. So that was the concept of limiting reactant. In the previous stoichiometry that we've seen, the questions were worded such that we told you what your limiting reactant was. We just said this amount reacts with excess of this. And so you didn't really have to worry about limiting or excess. And you only had 1 mole amount to work with. We only gave you sort of the mole value for one of the reactants, and you didn't have to choose what your limiting reactant was. Because remember, when you're predicting products or how much of something you can make, you need to look at what runs out first. And in those previous questions, we kind of just told you that. In these questions, where you get limiting reactant problems, you have to figure out what your limiting reactant is. So if I ask you, for example, how many grams of NaCl will be produced from 18 grams of sodium and 23 grams of chlorine? Here you're going to be given basically quantity for sodium, quantity for chlorine, and you have to predict how much NaCl is made. Well, what do you choose? Do you choose the moles of sodium or do you choose the moles of chlorine? If you choose the wrong one, if you choose the excess, you'll estimate more sodium chloride than you could actually make. If you choose the limiting, I don't know which one it is here yet, you'll estimate less sodium. You'll estimate the correct amount. So the limiting reactant is what you want to use. You have to choose the proper one. Now, it's not always the smallest quantity, right? It's not always the smallest mass or smallest number of moles, because the coefficients follow each other in a certain ratio. So you'll use up sodium twice as fast as you use up chlorine. So there's a bit of a trick you need to use to figure out what the limiting reactant is. So when you're solving problems with limiting reactants, where, for example, you're given the masses of 2 reactants as opposed to just one, you have to figure out what your limiting reactant is. And so I'll teach you a few strategies to do that in the next few videos. There'll be a few methods that you can use. And then once you have your limiting reactant, then it's just a regular stoichiometry problem. Then you use that limiting reactant to predict how much product is made using your mole ratios, and then you can convert to mass if you need to. So the extra step really is finding out what your limiting reactant is, and then afterwards it's a regular stoichiometry problem. Using that stoichiometry, using that mole of limiting to find whatever your product is. So in the next video, we'll go ahead and take a look at some examples of how that works. We'll take a look at how to determine what the limiting reactant is, and then we'll do some practice problems together.